Imagine, everything around us suddenly disappears. No Earth, no sun, no stars, no galaxies, not even space itself to hold anything at all, and not even time for anything to happen. We often think of the universe as a vast, empty space, filled with stars, planets, and galaxies. But there was once a moment when everything we see today did not exist yet. No Milky Way, no atoms, no life, no humans looking up at the universe, wondering where we came from. So how did the universe begin? And if it once had a beginning, could it also have an end someday? When we talk about the beginning of the universe, many people imagine a giant explosion, a massive explosion happening somewhere in empty space. But the Big Bang was not like a bomb exploding in space. Because before the Big Bang, space, as we understand it today, did not yet exist. The Big Bang was not an explosion happening at one point inside the universe. It was the expansion of space itself. It was not matter flying outward into an empty space that was already there. Instead, space itself began to expand. From a state that was extremely hot, extremely dense, and extremely small. All the energy and matter we know today were once contained in that strange state. Even space and time themselves were part of it. Then, about 13.8 billion years ago, the universe began to expand. And from that moment, the story of everything began. In the very first moments, the universe was so hot that no atom could exist, no stars, no planets, no light freely traveling through space. There was only an extremely hot ocean of energy. Particles appeared, collided, changed, and disappeared again. Everything happened faster than the human mind can imagine. A tiny fraction of a second. Far shorter than the blink of an eye. And yet, in that brief moment, the foundation of the universe was being laid. The first particles formed. The universe expanded. And as it expanded, it slowly cooled for hundreds of thousands of years. The universe was like a thick, hot fog. Light could not travel far. It kept colliding with charged particles. The universe was not transparent yet. But after about 380,000 years, the universe cooled enough for the first hydrogen atoms to form. And for the first time, light could travel freely through space. That ancient light still exists today. It has been stretched by the expansion of the universe. Now, we call it the cosmic microwave background. A faint echo from the early universe, and one of the strongest clues that the universe began hot and dense. After that, the universe still had no stars, no galaxies, only hydrogen, helium, and darkness. This was the cosmic dark age. It lasted for hundreds of millions of years. Inside that darkness, gravity began its quiet work. Gas gathered. Clouds collapsed, pressure and temperature rose, and then nuclear fusion ignited. The first stars were born. For the first time after a long age of darkness, the universe lit up. Those first stars were huge, hot, and bright, but they did not live long. When they died, they exploded as giant supernovae. And inside those explosions, the universe created heavier elements: carbon, oxygen, iron, calcium. The elements that would later become rocks, water, planets, and living bodies. That means we are not separate from the universe. The atoms inside us were once born in stars. Before they became part of life, they belonged to stars that died long ago. In a beautiful way, we are stardust thinking about the stars. From giant clouds of gas, galaxies began to form. Great cities of stars appeared in the darkness. In one of them, the Milky Way was born. And in a small spiral arm of the Milky Way, about 4.6 billion years ago, a cloud of gas and dust began to collapse. At its center, the Sun formed. Around the Sun, matter collided, gathered, and slowly became planets. One of those planets was Earth. At first, Earth was hot, violent, and chaotic. But over time, its surface cooled, oceans formed, the atmosphere changed, and somehow, life appeared. From simple life, evolution unfolded over billions of years. It created plants, animals, and eventually, human beings. Then one day, humans looked up at the night sky. They did not know that the stars had helped create them. They did not know that asking where the universe began was also asking where we began. But the story does not end there. Right now, the universe is still expanding. Distant galaxies are moving away from us, not because they are flying through space like fragments from an explosion. But because space itself is expanding, and the strange part is, that expansion appears to be speeding up. Scientists call the mysterious cause dark energy. We still do not truly understand it, but it may be pushing space to expand faster over time. So the next question is, where is the universe going? What will its final future be? One possibility is the Big Freeze. The universe may continue expanding forever. Galaxies will drift farther apart. Fewer new stars will be born. The gas needed to make stars will slowly run out. The stars that exist today will die. The sky will grow darker. Galaxies will become colder, darker, and emptier. After an unimaginable amount of time, even black holes may slowly evaporate through Hawking radiation. In the end, the universe may become almost completely cold, dark, and thin. No bright stars, no warm planets, no strong energy for life, only scattered particles, faint photons, and a darkness that almost never ends. This is the Big Freeze, the cold death of the universe. No final explosion, no dramatic ending, only a slow fading away, like a giant fire burning for trillions of years, then dying silently. But the Big Freeze is not the only possibility. There is also the Big Crunch. If gravity were strong enough, the expansion could slow down, then stop, then reverse. Galaxies would move closer together. Space would contract, matter would be compressed. And the universe could collapse back into a hot, dense state, like a Big Bang in reverse. There is also the Big Rip. If dark energy becomes stronger, space could expand so violently that everything is torn apart. First galaxies, then star systems, then planets, and finally, even atoms. But for now, we do not know how the universe will truly end. Big Freeze, Big Crunch, Big Rip, or something we have not imagined yet.